Casting is a manufacturing process where a liquid is poured into a mold and cools down to solidify. It is useful for creating products with complex surface patterns or irregular shapes that conventional machining tools would have difficulty producing. Casts can be used to shape metals, plastics, and food products. To create the mold, wax is used to create a desired shape. Another material is used to cover the shape, and the wax is removed to produce the mold. The types of molds that are used are permanent molds and expendable molds. Permanent molds are typically made of graphite or metals with high melting points. These molds can be used to cast metals with low melting points or plastics, but are limited in the types of shapes that can be produced because of the methods that are used to separate the cast from the mold. They are useful for mass production because they can be used many times before they become worn out. Expendable molds are different because they are typically made of sand, plaster, or ceramic. These molds can be used to cast more complex shapes than permanent molds. However, they can only be used once because the method of removing the cast involves breaking the mold. Large metal components and expendable casts are time-consuming to create because it takes a long time to create the mold and cool the metal. However, casting is ideal in mass production when making small metal components and using certain types of plastics that cool quickly. Die casting is a method which uses heat and pressure to produce small metal components to high tolerances. Casting typically produces products with lower tolerances than machined parts because the casted material shrinks as it cools in the mold. The casted item needs to be further machined and undergo sizing in order to reach the desired shape.
Forming is a process in which a material, usually a metal but occasionally plastic or sometimes even a wood, is plastically deformed under various types of loading or a combination of these types of loading, compression, tension, bending, shearing. And the objective is to deform and displace the material, however, not to add or subtract any of the material. So the only thing changing is the surface area, the shape, the dimensions, but not actually the mass or the volume. And it is typically used to create anything from angled iron bars to sheet metal objects, all the way to copper wire or 3D filament, 3D printer filament. Um, Forming typically creates cylinders, rectangular prisms, or other common geometric shapes. And since forming is classified as having extremely high loading, it's necessary to use high quality components in the machinery. And when you're using high quality components, that usually means high cost as well. So forming is a very cost expensive process. Shaping, on the other hand, is a process in which material is removed from an object in order to create a new desired shape. And the most common form of shaping is wood planing. Wood is the most common material to be shaped, but you can shape metal as well. Shaping is usually used for furniture pieces, wood dowel, or even to get deformities off of a surface. Shaping is surprisingly expensive. It's more expensive than horizontal boring or milling, and the tolerances on shaping are pretty inaccurate. They're more inaccurate than turning or grinding. And machining in general is very expensive since it takes a lot of time to change from one machine to another in the machine process.
Machining is a subtractive process. A part is placed in a machine such as a lathe, mill, or drill press, and material is removed from it. This is done for a few reasons. Machining improves the dimensional and geometric tolerances of the raw part and usually improves the surface finish. Standard dimensional tolerances are plus or minus 5 thousandths. Standard geometric tolerance are 5 thousandths total, and standard surface finishes are about 125 microinch. In a lathe, the part spins and the tool is stationary. This is ideal for round parts like shafts, for example. Here, a bearing bracket I designed a few years back is being machined from a casting in a lathe. A faceplate will be pressed in the bearing bracket at the next stage of assembly, so very smooth, flat surfaces are required. This is a drill press. In this type of machine, the part is stationary and the tool, usually a spiral drill bit, spins to drill holes. A mill is very similar to a drill press. The part is stationary and the tool spins. What makes a mill unique is the table that the part is mounted to can move side to side. This XYZ movement allows for complex shapes to be taken out of raw stock. The tool used must be able to cut material sideways, unlike a drill bit that only cuts in line with its axis. Machining usually takes less than 10 minutes per part. Larger complicated parts could take a few hours, but small parts only take seconds. Generally, metal parts are machined, but many plastic and composites are also machinable. It's more expensive to machine a part than to cast it right to size, but machining is only considered when closer tolerances are required than can be achieved in the raw part form. There's a large initial investment in equipment, but the equipment lasts quite a while. Here's a lathe that was manufactured in 1941 and is still in use today making manifolds. Here's a before and after picture of the bearing bracket. The bracket is now ready to move down the line.
Includes processes such as welding, brazing, soldering, adhesive bonding, as well as mechanical assembly. Welding, in this process, two or more parts are heated and melted or forced together, causing the joined parts to function as one. Brazing, during this process, a filler metal is attached and distributed in between multiple solid metal components after they've been heated to the proper temperature. Soldering is similar to brazing, the only real difference being that soldering has the melting point of the filler metal below 840 degrees Fahrenheit. In adhesive bonding, a filler metal material called an adhesive is used to hold multiple closely spaced parts together through surface attachment. In mechanical assembly, various fastening methods are used in mechanical assembly to mechanically attach two or more parts together. The purpose of joining is to join parts together, including any multitude of material. Different materials require different methods that I've previously mentioned, requiring different time constraints as well.
Hi, I'd like to discuss some surface finishes for machining processes. The most common would be final machining, which would leave the material in its raw state. This is only acceptable for materials with low carbon, such as stainless steel, aluminum, and other alloys. This will help these materials not rust due to the lack of carbon. Surface finishes such as RA and micron levels can adjust the smoothness of the material. Knurling can be added for additional grip, usually in radial applications which require torque, and hand application products such as hardware. Painting would be another type of surface finish. This requires cleaning the material, prepping an area, utilization of support equipment, ventilation, and proper personal protection equipment such as safety glasses and possibly a respirator. Priming the material provides extra adhesion surface, and then painting is needed along with the final clear coat that could possibly increase costs. Powder coating is another type of surface finish that can be added to a material. This is applied electrostatically from a negative charged element to a positively charged material. Two types of powder coat include thermosets and thermoplastics. Thermosets react with the base component, improving performance. Thermoplastics just bake on with the initial flow coating. Plating can also be used, which covers a conductive surface with a thin metal deposition. This will also increase corrosion resistance, reduce friction, and can possibly alter conductivity. Gold plating is used for electronics. Chrome plating is used for corrosion resistance and decorative appearance. Zinc plating can be used most common and is best for corrosion resistance. Silver plating is often used in household items such as silverware and baking equipment.